So I'd like to introduce the panel. The Industrial Internet Consortium is, as Greg, thank you for the introduction, Greg. And thank you for the few of you who read the stuff that said that there was going to be, that it's supposed to be business casual. You make me feel a little bit better. My panelists obviously can't read. Yeah, we're going to mix it up. We're going to be exciting today. I don't know where that goes. We've got a great panel today. I'm going to give you an introduction about the Industrial Internet Consortium, which is about 10 months old, almost 11 months old now. Giving you a reason for why we pulled it together and what we're doing. And we have some exciting announcements about the Industrial Internet Consortium next week. Oh well, sorry. We'll probably try to interlace some hints into what I'm saying, but the most important talks today will be by three prominent members of the Industrial Internet Consortium. So from left to right, we have Katya Golovchenko. It's very easy to say. I've been working on it for days. Katya is a fellow scientist and corporate technology, which I thought was funny because she doesn't look like a fellow to me. Next, in the middle, JP Provencher is Senior Director of IoT Solution Strategy at ThingWorks, which is, as most of you probably know, part of PTC. And then holding up the right there is Jamie Smith, Director for Embedded Systems at National Instruments, all of whom are working on various interesting projects at the Industrial Internet Consortium. So let me introduce the consortium now, or at least try. That never works. So I'm going to actually say a lot of the same things that Dr. Achatz said, but perhaps from a different direction. We come at this from the direction of internet thinking, and that phrase is going to come up a lot in the 10 minutes that I give as an introduction. I start from the famous Gates memo to all Microsoft employees in 1999. He said, "The internet changes everything." How many people agree with that, by the way? He's the richest man in the world again, so you've got to agree with him. How many agreements? We got 3 people who agreed. The rest of you are already asleep. Thank you very much. I mean, before I get into why he was wrong, I'll tell you why you might think he's right, because none of you listen to music from those. Remember those big black discs? No, some of you have hair. You probably don't remember it, but we listen to music on computers now. We watch movies on computers. We read news on computers, except for some reason in Germany people still read newspapers, but you'll probably notice here there's no such thing as a newspaper. The closest thing is USA Today, which is television and 4 sheets of paper. Anybody here from Gannett? Thank God. But in fact, there are some interesting markets where the internet has not had much of an impact. So in 1979, when I was 2 years old, I worked for. People often laugh at that. I worked for a company called Modicon, and I'm sure a lot of people in this room are aware of Modicon. Any people from Schneider here today? Yeah. Modicon was later called Gould, and then it was spun back out as Modicon, and now it's called Schneider Automation. And what I was working on actually was AI systems that diagnosed failed Modicon 584 programmable controllers. And anybody remember how you programmed a programmable controller in 1979, 1980? Ladder diagrams, right? Remember ladder diagrams? Here we are 35 years later. What do we use? Ladder diagrams. So everything has changed. Actually, more important, the way we connect operational systems, OT, operational technology, to the technology that drives the business, the information technology, is the same way we did in 1979. That is, we don't. If you want information from well, of course, that's another picture of a 584. I don't know why. The 984 is much cooler. Its sides are made of plastic. If you want to get information from that and do something interesting with it, connect it to your inventory management systems, for example, it's probably going to involve, at best, copying something onto a stick and then copying that stick onto a computer somewhere in the IT systems, and at worst, printing something out and typing it back in. There's a bunch of other, yeah, I heard some snickers, so I know some of you do that. There are a bunch of other markets that look the same. In 1950, most energy grids in the world, like the 3 in the United States, that would be East, West, and Texas. That's not a joke, by the way. That's true. We have some energy grid people in the room. I'm sure I see some shaking heads. they were designed to assume that there were a small number of power generators and a large number of power users. Of course, that's changing rapidly with people putting solar arrays on their roofs, and with people driving around with very large battery packs in the back of their cars, like my Mexican car, a Ford. 2000. You guys are not going to give me even one laugh for free, right? They pretty much look the same today, and although we were discussing this at lunch with the panel, everybody says, yeah, we're working on all kinds of really cool things that are going to change the electric grids of the world. And yeah, there are about 12 microgrids where people have done some interesting work, but there's not a whole lot on a nationwide scale anywhere in the world. One of the more interesting ones to me, because I'm an aviation buff, is, as you probably know, anybody in the aviation engines business? Nobody. So, okay, I get to teach you and make it up and you'll never know. Av engines collect data, enormous amounts of data. One of the big Av engines, like a GE90, one of those huge things you could drive a truck through if there wasn't an engine in it, that's on the wing of a 777, collect a lot of data, performance data, while the engine is in flight, up to a terabyte per hour. So you'd think that when the plane lands, it would use the Wi-Fi that's in every airport to upload that data to the engine manufacturer, who could do something with it, like do some predictive real-time analytics and warn the maintenance base that if they fix the blade on the third-level compressor on the high bypass, on the low bypass, sorry, they could get 1% more efficiency out of the engine. In fact, what really happens is, it's still downloaded by hand, at best by cable, 2014, so this is an old presentation, it's like a month and a half old. Still true in 2015, it hasn't been fixed in the last 2 months. And that despite the fact that the model is changing, as as Dr. Achatz mentioned, you're seeing some changes in the way things are sold because of the Internet of Things. And actually, I think the most interesting is in the aviation business, where most aviation Av engine manufacturers are starting to sell propulsion as a service. Thank God they're not calling it the cloud, but that's essentially what it is. And the interesting thing about that, from the perspective of the airline, of course, is that they're moving their capital expense into an operating expense, so they can directly relate it to their operational revenue, that is, seats filled with people. But from the point of view of the manufacturer, it's interesting because it moves the service from the airline to the engine manufacturer, which is a big change, and obsolescence is no longer quite as exciting to them as it might have been beforehand. I look at this as a disruption very much like two disruptions we've seen before, which were intimated by all three of the previous speakers. In the late 19th century, we moved brawn into steam, and then electricity and other things. That's the Industrial Revolution. In the late 20th century was the Internet Revolution, where we took a lot of the intelligent systems that are out there and moved the intelligence into the computers from people. I think you need to take that Internet revolution and apply it to the Industrial Revolution. There's a bunch of different reasons. I think the most important is that we saw enormous productivity gains, GDP gains, when we went through the Industrial Revolution and the Internet Revolution, and I think we can see it again, whether you call it the third Industrial Revolution, as Jeremy Rifkin calls it, or the fourth Industrial Revolution, as we've just heard, or what I call the Industrial Internet. That is, applying Internet concepts to industrial systems. Basically, applying Internet thinking to industrial systems. And I'll give you one story based on my own experience, having been invited to a conversation of energy grid designers that design and maintain the three major energy grids of the United States. They invited me because they said they had this big communications problem because they want to track essentially temperature across all of the major all the major power links in the United States. They were generating, they said, huge amounts of data, and they didn't really know how to get that back to a control room. So I said, well, here's an envelope, here's a pencil, let's figure out how much data it is. And after, I won't go through the tedious conversation, but at the end it came out to 2 megabytes a day. A day. And I said, well, I've got 2 megabytes a second coming into my house. And at least one of the engineers in the room said, oh yeah, so do I. It's that application of Internet thinking to industrial systems that we're starting to see. God knows why that was animated. Why do we care? As you notice, I don't like animated slides. Why do we care? Because the opportunity is enormous. And now, Of course, all analyst estimates are always correct. I want to just point out that the ARC guy just left. So just to give you some numbers, GE calls it a $32 trillion opportunity based on a $70 trillion global GDP. They figure about 46% of the world GDP could be impacted by industrial internet. Cisco calls it, increase private sector profits by 21%, add 19 trillion to the global economy by 2020. I mean, you can read these as well as I can, and they actually come out to basically the same sort of thing. It's a huge opportunity. That opportunity, as we've heard, comes from revenue generation. There are new opportunities to use information in different ways to make our systems more efficient, but also drive operational efficiencies in the production of products and in the products themselves. For example, you heard that ThyssenKrupp elevators and escalators call home and say, bring part A, B, C, 1, 2, 3, because I'm about to fail, even though my owner doesn't know about it. And we've already seen this happen. We've already seen owners of industrial devices be surprised by a service guy at the door who says, your system's about to fail and I've got the part to fix it. Reduced waste, material, energy savings, and so forth. But I think the most interesting that is going to come from smart connected products, and you're going to hear more about that later in the panel, are improved service levels that generate improved customer satisfaction. GE did a great study. It was published by their chief economist, Marco Annunziato, about 3 years ago. Their study was they were looking at what kind of changes in the world we'd see from a 1% increase in efficiency in various markets over 15 years. They claim just GE engines, which is one of the larger jet engine manufacturers, a $30 billion savings from a 1% efficiency increase over the next 15 years. So, I mean, if you care about a $30 billion market, that's interesting. $66 billion for diesel engines. They see 92 million vehicles with internet connectivity on the road by 2016. That would be next year. Mind you, the self-driving cars we're seeing are not really integrated, right? All they do is replace the driver. Things become more interesting when cars talk to each other saying, I'm about to crash with you, maybe you should go faster or I should go slower. Or cars talking to the roadway, and the roadway saying there's an accident 10 miles ahead, there are 7 detours. The third detour has the best flow at the moment, take the third detour. And before you say, well, that's kind of crazy, let me point out that is precisely what we've been doing with airplanes for decades. Airplanes look for each other in the sky, and if they see each other, they use a system called TACX, and one of them tells the pilot to pull up, the other one tells the pilot to push down, and they avoid each other. And of course, we use a worldwide control system, not all that well integrated, but at least it exists to make sure that they don't run into each other in the sky. It's really about applying internet technology to operational systems. And I think actually you did a great job discussing why now is the time. The technology is here now. This is not something we should think about for the next 10 years. This is something that is being applied, has been applied, and my panelists are going to talk about some specific applications. Sensors are cheap, actuators are cheap, processing power is free, memory is free, everything's connected, and we have great technology for big data and smarter machines. So we could hope that all the different players in this world, the standardizers, the big data companies, the industrial players, the technology players, and so forth, would make all the right one-to-one connections and find that opportunity and create this market. But that kind of collaboration takes a very long time, and you can probably do better. And that's what the Industrial Internet Consortium does. Brings together those players to work together to develop test beds and prove out industrial internet technology in real systems. And even before we develop standards, that is, let's actually go build systems, see what works, take the result and figure out where the disruptive new products and services are, and also figure out what standards are necessary, especially in the semantic realm, to solve those integration problems that are so difficult to do. That's our mission: accelerate growth of the industrial internet by coordinating ecosystem initiatives to connect and integrate objects with people, processes, and data using common architectures, interoperability, and open standards that lead to transformational business outcomes. Most important part there is transformational business outcomes. We are just trying to change the world, that's all. Launched in March 27th of 2014, so about 10 and a half months ago, by 5 founding members, General Electric, IBM, Intel, Cisco, and AT&T. I change the order every time, by the way, if you're one of those 5 companies. We planned to expand to 50 members by the end of 2014, and as of this morning, there are 140 members that are participating in those activities. You don't really care about growth, so I'm going to skip over that. They include all of the members on the panel, but quite a few others in every geography of the planet. If you're looking for your logo, I took it off specifically to make you angry. Yes, you. So there are a lot of large industry players, well-known names like TE and Mitsubishi and PTC and Parker and Toshiba and Fujifilm and ABB and so forth. But there are also a very large number of smaller companies whose names you may or may not recognize, because a lot of innovation comes from small companies. A lot of innovation comes from small companies that get eaten, like ThingWorx and Exida, for example. These companies bring a lot to the fore, everything from the low-level technology stack to the high-level semantics of jet engines maintenance so that you can integrate jet engine information. There are also a small but growing number of academic and research institutions and organizations like United Laboratories, which would like to start testing these devices and putting their seal of approval on them. So just to give you a feel for the sort of organizations that have been joining over the year. What we're doing is bringing together all of the members of that ecosystem. So to give you a feel, the technology companies, big data companies, standardizers, open source organizations, large industry, users of Internet of Things technology, large software and hardware vendors and so forth. Bringing them together to develop technology roadmaps, reference architectures we call them, and security roadmaps, and using those not to develop standards but to build test beds. At this point, there are 4 approved test beds. We have not announced any of them yet. We will be announcing one next week. And as I say, the test beds are aimed at finding disruptive, transformational business outcomes. There are 12 or 14 more test bed proposals that are coming through the process now, so we expect a fairly large number of test beds to be announced this year. We'd love for you to participate. Pretty much everybody I've talked to already is already participating, but the quick and easy way is to actually become a member and more importantly, participate in the development of requirements in our technology adoption processes, which is figuring out those reference architectures, what standards already exist, what standards need to be developed to build those test beds, and figure out what is the direction of the industrial internet. This is not going to happen. No one company is going to do it. This is an ecosystem play where everybody's got to participate. It's also a great opportunity, as is this show, for example, to network and find other companies that are doing similar things. The future, as I said, I hate builds. The future is jet engines that upload their information in flight so that we know where the plane is, for example. But also so that you can actually get information to the maintenance base while the plane is still on the ground, rather than about ready to fall out of the sky. As planes spend less and less time at airports, low-cost carriers often have their planes at the gates for 25 minutes. The importance of getting real-time predictive information about the status of the aircraft and the engines rises. Minimizing factory downtime means understanding all the different pieces in the factory, and I think, again, a great example by Dr. Achatz, who talked about doing a better job of optimizing the connection between the robotics in a factory and the people in a factory. If you've never seen that device on the right side of the picture, this is one of my favorite examples of where we can change the world in positive ways. That's an oxygen sensor, or O2 sensor. It looks through your skin into your body to guess how much oxygen is in your bloodstream. It turns out it's a fairly important number. Falls below a certain number, you don't have to worry about it anymore. O2 sensors don't work. They have a 20% failure rate because it turns out we have different color skin with different translucency and so forth. Unfortunately, nurses know that. And if a nurse gets an indication for example, in an intensive care unit, ICU, that a patient has a low oxygen number, he or she is likely to ignore it once or twice before bothering to check. This despite the fact that we also know that if your O2 number is falling and your respiration number is falling, you're in trouble and they should get the crash cart and do something about it. So you'd think, well, all you got to do is integrate the respiration sensor and the O2 sensor. Unfortunately, there are no vendors that build both of them. There's no respiration and O2 sensors that sit on the same bus or speak the same protocol. So, oh well, we lose a few people. Yeah, we can save some money on liability and we can save lives if we do that better. And we can also roll up information from apparatus like these on individuals into population health data, and there are people working on that as well. So I just want to say things are coming together. We'll be announcing, as I mentioned, our first public test bed next week. There'll be a couple more announcements over the next couple of months of test beds that we have underway. There's quite a few others being developed, actually even at lunch today. I've asked these three smart people to give us stories, talk about systems that they've actually seen that apply internet technology to industrial systems. That's what we call the industrial Internet of Things. And then we should have some time, until Greg says we don't have time, to quiz us. So thanks for coming today, and I hope you enjoy the panel's presentations. We're starting with Jamie.